External Great Connection. Each leap in human evolution has led to a new breakthrough in the expansion of energy loci. Human beings' gradual dominance, in terms of nutritional energy intake, is sufficient to make them proud against any competitor in the animal kingdom. From the early days of hunting and gathering to later agrarian societies, there was a significant shift in the uncertainty of human energy intake, and the concerns related to food and clothing for survival were no longer daily concerns. From agrarian societies to industrial societies, human understanding of the world has grown rapidly, with more mastery over forms of microenergy existence and the rules of nature, establishing a closer connection with all living and non-living forms in nature. From macroscopic to microscopic, from small scale to large scale, from living organisms to non-living things, the connection between human beings and the outside of the organisms appears to have surpassed the nature and boundaries of life as initially recognized. Domesticated connection. From an energy balance standpoint, domestication does not appear to be a one-sided action. For domestication to succeed, a win-win situation must be reached, where both parties' needs are met in balance. Domestication should not be confined to the mere survival and reproduction of one species used and controlled by another. Rather, it should attain a two-way interactive and relatively balanced relationship. This association can only be described as a proximity to a symbiotic relationship, which does not mean they are fully independent of each other, nor does it rule out the presence of some parasitism in this relationship. Both parties involved in domestication maintain a certain degree of independence. If a sudden disconnection occurs, it is believed to have no catastrophic consequences for either party. It is commonly believed that humans began domesticating plants like wheat and peas at least 12,000 years ago. This book argues that the time when humans established a formal connection with plants could have occurred even earlier. It could have happened at the beginning of human hunting and gathering, when human ancestors were still in the early stages of establishing this connection. This speculation is not baseless, and the following logical counterargument supports it. If humans had harvested wheat recklessly, wheat would have gone extinct. Had humans not inadvertently helped spread wheat seeds, wheat might have remained a wild plant constantly threatened by other animals. If humans had not intentionally or unintentionally trampled weeds when gathering, then wheat might have barely survived among the weeds. If the gatherers of that time were allergic to wheat's gluten protein, humans might not have established a relationship with wheat. If wheat had not hybridized with goat grass, its low yield and less tolerance to environmental conditions would have made it the least viable option as human food. The relationship between human ancestors and grains is known as the domesticated connection, formed through uninterrupted interactions during food gathering and long-term interactions. At maturity, the unbroken spike of wild grains divides into spikelets, the fruit-bearing flowers of the wheat plant during reproduction, and subsequently disintegrates, leading to the production of fruit. The fruit is then dropped on the ground, waiting to be picked up by passing animals. As a result of frequent hunting by humans, other animals have decreased their activity around the area where the grain is found. Following an extended period of this situation, there has been a significant evolutionary leap in the genetic makeup of individual wheat plants. The timing of fruit breaking and shedding was no longer synchronized. Instead, they preceded and followed each other in different plants. This provided human ancestors with more opportunities to collect fruits from grains as food, and they inadvertently discovered that the fallen fruits could grow. Consequently, humans began intentionally planting seeds and selecting those that were more durable for cultivation. Grains also exhibited a high level of cooperation in evolutionary terms. After multiple generations of selection and breeding, the shattered ears of wheat were ultimately tamed into non-shedding ones. Since then, humans have extensively propagated and cultivated wheat expressing the non-shedding ears gene. The domesticating connections between humans and other animals is both the same and different. This similarity results from the fact that humans and animals typically undergo a lengthy period of interaction before achieving a stable and strong domesticated relationship. However, it is worth noting that humans and animals are part of the same higher bioactive organism and have strong interactions. It is widely acknowledged that animals were domesticated by humans at a much higher rate than plants. For instance, consider the domestication of sheep. According to many scholars, the domestication process followed a similar pattern. Early human hunters used to catch a lamb and raise it only to slaughter and consume it when food was scarce. As the number of raised sheep increased and more lambs were born, humans began selectively breeding only those with desirable temperaments for food production. This meant the more docile ones were left behind to continue breeding. In this way, humans were able to successfully domesticate sheep. This speculation appears unconvincing. To begin with, the populations in those days were likely not big enough to face food shortages in areas where they were capable of gathering or moving. Additionally, under such circumstances, early human ancestors probably wouldn't have come up with ideas regarding breeding or domestication. Secondly, the wild lambs that were suddenly captured at that point in time could not have had an extensive area to graze, leaving them without enough food to survive at the same rate as before. Furthermore, even if ancestors domesticated animals to ensure survival, they might have ended up breeding animals that were difficult to domesticate, like zebras, for a consistent food source. Lastly, raising sheep was not always an economically viable activity. Furthermore, ancestors had to go through the hassle of protecting them from other predators that could exploit the opportunity. Sheep were among the main targets of hunting before the establishment of the domestication link with human ancestors. The consumption of sheep meat was not the only way our human ancestors obtained energy. Still, the sheep's fur was particularly significant. Following the migration of Homo sapiens out of Africa, the biggest challenge was to keep warm during winter, and sheep's fur became a preferred and cold-resistant garment for them. As the population expanded, the shortage of clothing became a growing issue. By developing a connection with sheep, Homo sapiens eventually learned the traits of sheep herding and started settling around the sheep populations, while only hunting and killing a part of them, keeping the rest for breeding. This provides sheep with a stable source of wool. Homo sapiens then selectively hunted the more aggressive sheep while allowing the more docile ones to breed. Surviving in an environment with fewer predator attacks, sheep were able to experience a relatively happy life, which enabled them to form stronger bonds with humans. Over time, due to a significant genetic evolution, these sheep, bred in captivity, learned to interpret human behavior and no longer perceived the proximity of humans as dangerous. The domestication of the human-sheep stable connection is complete at this stage. The process of domesticating dogs is generally more pleasant. After the discovery of spears, cooperative hunting became greatly more efficient. During that period, as a result of the abundance of their food, gray wolves began to follow human trails hoping to scavenge food scraps. These gray wolves, sustained by a food source, stopped attacking humans and instead trailed the footsteps of Homo sapiens for an extended period. Thanks to the sharp sense of smell and hearing of wolves, when a new intruder approaches at night, the wolf howls to signal a warning. Upon hearing the howl, nearby Homo sapiens take the necessary precautions. Over time, gray wolves and the Homo sapiens tribe gained a mutual understanding, forming a kind of community. Through a prolonged connection and evolutionary process, a wolf cub seemingly made a leap in understanding human emotions and behaviors, becoming willing to approach humans. This close interaction started to change the gray wolf into a canine. Domestication of plants and animals has independently occurred in at least 11 world centers and has resulted in the domestication of numerous species. Throughout history, humans have domestically cultivated 5 major groups of plants, namely cereals and other grasses, legumes, root tubers, melons, and fibers. Domestication of animals has also been a great success, with almost 50 species having been domesticated, ranging across mammals, poultry, fish, insects, pets, and birds. What accounts for human success in domesticating numerous plants and animals? One possible explanation is that, after humans accidentally managed to domesticate some species, they gradually became aware of the existence and process of domestication. The concept was widely propagated during the migration of Homo sapiens, and individuals everywhere experimented with domestication and new methods of artificial breeding, depending on local conditions. Nevertheless, most of the artificial breeding was unintentional, and the ties to domestication were still very rudimentary. With Homo sapiens learning deliberate artificial selection, the domestication link reached a relatively advanced stage. All previous endeavors were further intensified and accelerated as the area of wheat cultivation and the scale of sheep breeding underwent a dramatic expansion. Another reason relates to human activities such as intermarriage, migration, trade, and war. Livestock such as dogs, sheep, pigs, cows, horses, camels, chickens, ducks, and others were first domesticated in Eurasia. Given that interactions, migrations, and integrations among communities across Eurasia were more frequent than among land communities separated by oceans, the exchange of domestication knowledge and the introduction of breeds occurred more readily. Consequently, it did not take long for these domesticable species to spread rapidly across all human habitats in Eurasia. Africans were the first to domesticate donkeys, cats, and pearl chickens, while Americans were the first to begin the domestication of maize, potatoes, alpacas, turkeys, and guinea pigs. Furthermore, these domesticated animals were introduced to each other through broad human connections. Naturally, the spread of domesticated plant and animal concepts, behaviors, and knowledge across oceans was still partly due to chance. The exchange of domesticated species between the American and Eurasian continents finally began in the 15th and 16th centuries, during the Age of Discovery. It was after the mutual introduction of rice, wheat, maize, and potatoes that the resilience of human agricultural societies against famine was significantly transformed. If there had been resistance and technological thresholds on both sides of domestication before the widespread dissemination and introduction of domesticated species, then it is estimated that most Homo sapiens on Earth would still be living as gatherer-hunters today, similar to Aboriginal Australians before European discovery. Invisible connections. Cell differentiation makes microbial symbiosis possible in a multicellular organism. The human body is composed of tens of trillions of cells, and technically speaking, it's a combination of human cells and over 1,000 varieties of microorganisms. Parts of the body previously believed to be microbe-free may contain multiple microorganisms. The attachment of a microorganism to the human body creates a genetically mediated symbiotic relationship and may play a pivotal role in promoting mutually beneficial interactions between the microbe and the host cells, thereby maintaining the healthy functioning of both. It has been conventional to assume that the fetus, human brain, and spinal cord are sterile. Recent scientific research indicates that this notion may be incorrect. From another perspective, there is no valid reason for the human body to be sterile in the tissues of all its organs, whether fetal or adult. Why is that? First, the organism cannot prevent microbial invasion on a cellular scale. Second, the immune system must closely cooperate with the commensal bacteria of each organ. Only when every symbiotic bacterium is in place and functioning properly can the human body operate effectively without chaos or dysfunction. Prior to birth, the fetus should have acquired a small number of bacteria from the mother. This doesn't necessarily need to be in large quantities, but there should be a sufficient variety of essential bacteria. These bacteria penetrate in advance to take up their positions and establish lines of communication and countersigns with the immune system. Aside from the innate association of human cells with symbiotic bacteria in vivo, humans are also linked with other microorganisms, including non-symbiotic bacteria, viruses, fungi, and chlamydia on both the body surface and in vitro. It is likely that yeast was the first microorganism to establish a domesticating connection with humans. Yeast-fermented wine slowly became a dietary staple following ancient people's accidental discovery of its sweet, refreshing taste and long shelf life compared to grain preservation. Yeast, with its diversity and ubiquity, has been fermenting in ripe wild fruit for 120 million years since fruit first appeared on Earth. Upon consuming sugar, yeast releases carbon dioxide and ethanol, which acts as a nutritional energy source for the body and is eventually broken down into acetaldehyde, then acetic acid, and finally transformed into carbon dioxide, water, and heat. Acetaldehyde acts as a relaxant and is capable of reversing the anxiety response. Given its relaxing properties, this relaxant can reverse the anxiety response, resulting in a calming effect on humans, who are typically known as the anxious animal. When the ancients first experienced this sensation, they naturally started to fall in love with it. Eventually, ancient people discovered how to employ yeast as an energetic agent to create artificial wine with a higher ethanol concentration than natural brews. Consuming too much or too strong wine impedes your body's ability to metabolize ethanol swiftly and thoroughly, leading to increased and stimulant-like effects. As a result, wine has become an indispensable part of human socialization, entertainment, and rituals. Disturbances in an organism's biological functions, or the failure of self-stabilizing regulation, can lead to the breakdown of the connection between the master cell and microorganism. Changes in the number of symbiotic bacteria performing their respective functions can trigger a catastrophe in an organism. On one hand, the energy imbalance results in surplus supply at some energy loci, causing the corresponding bacteria to be well fed. These bacteria multiply rapidly, leading to a dramatic increase in population pressure and migration to other organs. This migration leads to a conflict between the new immigrant bacteria and the native bacteria, also triggering the immune system to respond by sending immune cells to eliminate these new immigrants. This situation inevitably neglects other aspects, and the immune system gets diverted from its main role, therefore unable to attend to possible crises on other defensive fronts. Furthermore, the energy imbalance leads to an inadequate supply of certain energy loci. As a result, the bacterial strains associated with these energy loci undergo significant food deprivation and a sudden reduction in population, respectively. The situation gives an opening for potential pathogens to invade and siphon energy in large quantities, multiplying quickly and occupying more energy loci. In either scenario, pathogens can infect the organism, disrupt normal physiological functions of the host, and pose a threat to the community. As humans have more domesticated connections with animals, they are exposed to new microbial species at a higher level, which increases the associated risks. Initially associated only with domesticated animals, symbiotic microorganisms may mutate and become unrecognizable to the human immune system. Alternatively, they may become capable of directly attacking the human immune system after prolonged contact with humans and breaking through the body's multiple lines of defense. Certain microorganisms that initially infected pets have developed to infect humans. Humans frequently contract infections when in close proximity to domesticated animals. Some human illnesses have been found to have evolved from infections in our kept pets, according to molecular biologists. As an instance, measles and tuberculosis originated in cattle, while influenza came from pigs and ducks. Plague, an incredibly contagious, super-lethal disease among human beings, presents the most striking connection between humans and microorganisms. Several of the microorganisms that produce plague are affiliated with animals. Besides the microorganisms that domestic animals carry, other parasites such as fleas and rats that beset wild animals have caused significant harm to humans. For microorganisms, particularly pathogens that cause epidemics, the crucial strategy for obtaining energy and establishing themselves is to multiply and mutate rapidly. These microorganisms have developed a high tolerance, enabling them to stay dormant for long intervals. When conditions are favorable for an evolutionary progress, they unleash massive powerful attacks that are highly dominant, as in the case of a siege. Theoretically, human defenses are also not prone to vulnerability. Throughout the long-term interactions between humans and microbes, humans have developed proven mechanisms for fighting pathogens and ways to survive in harsh conditions. One of the most effective defenses is voluntary mutations, primarily in human leukocyte antigen (HLA) genes, which are the most variable genes. Each HLA gene has 10 or more significant variations, with some having as many as 100 or more. Voluntary mutations result in the codominant HLA system in any two individuals, except monozygotic twins, rarely being the same. Typically, the efficiency of a pathogen's attack on the human body depends only on the individual. An individual's HLA genes do not make them immune to a specific illness. Nevertheless, when a population can produce many variations of the HLA gene, they can recognize and protect against a category of pathogens as a whole, significantly increasing their chances of survival. When a pathogen enters the body, it must quickly kill the host before the immune system can detect it and enhance its recognizing abilities. Widespread infectious diseases could not exist before humans entered agricultural societies because those diseases required a dense, large host population to spread. However, after humans formed agricultural societies and cities, the high density of population gave pathogens new opportunities to breed and spread. Pathogens spread rapidly, infecting HLA gene carriers who cannot efficiently recognize them. Affected individuals quickly develop the disease, and the mortality rate may climb quickly, especially when several unnatural factors overlap. The Black Death in medieval Europe was among the worst disasters in human history. Scholars estimate that the Black Death caused the deaths of about 30 to 60% of the entire European population. There is significant diversity of HLA genes even in small villages in continental Europe, which leads to the presence of certain HLA alleles in the local population. These alleles can aid the immune system in quickly and accurately identifying Yersinia pestis bacteria, allowing the body to successfully eliminate or suppress them. During the plague that accompanied the European conquest of the New World, the indigenous peoples of the Americas experienced substantially higher mortality rates than their European counterparts. During the plague outbreak, the mortality rate among Europeans was approximately 1/3, whereas among the indigenous peoples of the Americas it was as high as 90%. Even in the 20th century, some other Native American peoples lost between 1/3 and 1/2 of their population within the first 5 years of contact with Europeans. According to the majority of scientists who have researched HLA alleles in Native American peoples, the tribes are substantially less diverse than Europeans in this regard due to lower intermarriage rates and territorial dispersion. A lot of tribes have over a 50% probability of possessing the same type of HLA gene in their population, and each tribe demonstrates some allele dominance. I disagree with this opinion, since the evolutionary principle of voluntary genetic variation cannot uniquely favor Eurasian humans. In my opinion, American Indians must not differ significantly from Europeans with regard to HLA genetic diversity. They could have prevented such a high mortality rate while confronting a specific Eurasian illness brought by European colonizers. According to historical records, Europeans unintentionally introduced multiple pathogenic diseases to the New World, including smallpox, bubonic plague, typhus, leprosy, whooping cough, and dengue fever. The impact of these lethal pathogens attacking simultaneously caused high levels of terror and despair among the Mandan population, resulting in an unparalleled disaster. The outbreaks of epidemics in Europe and Asia were not concurrent at that time. Instead, they were the remnants of thousands of years of separate emergence and mutual confrontation. Unfortunately, in the New World, when several epidemics combine and launch a three-dimensional attack, it becomes extremely difficult to resist them for any community that hasn't been previously exposed to those pathogens. It is estimated that if Europeans were in the same situation, the death rate would have doubled, or the population could have even collapsed. The Australian Aborigines and Polynesians also experienced the same fate, even though they had minimal contact with Eurasia. In contrast, the variety of pathogens that could affect people from the Old World in the New World is minimal. The only known diseases are syphilis and diving flea disease, and neither of them is highly contagious or lethal. The severity of the plague was different from that in the New World when Europeans invaded Central and Southern Africa, as well as the Philippines. These areas may not have been as isolated from Eurasia as the Americas were. Despite significant transport barriers, it is likely that local indigenous populations had at least intermittent and low-level contact with people from other regions. In the presence of minimal intermarriage and trade, there will be some degree of contact and transfer of pathogens and alleles in these areas. This is why the intensity of pathogen attack is highly affected by the long duration of time. Therefore, Africans and Filipinos do not have a genetic predisposition to an inherent special evolutionary advantage at the biological level. Abductive, inductive, and deductive reasoning. The evolution of language has brought humans closer to the world. Our perception of the world starts with the recognition of our five senses and their processing by the brain. The process gradually extends to other organs of the sensory system, which are finally integrated into our perception of the world. When humans recognized information, formed it into speech, and defined it in the speech center, our ancestors must have been full of expectation and curiosity about the unknown that they encountered. Wow! Trees, fruits, flowers, sunlight, water, earth, and squirrels. The scenario resembles the wonder and delight of a young child presented with a beautiful and expansive painting, identifying, one by one, the names of the objects depicted by each line and block of color in it. This scenario depicts how the world gradually becomes apparent in our minds. During the initial cognitive stage of human ancestors, daily life was characterized by the ability to take shelter under natural caves to shield against wind and rain during rainy winter conditions, the use of the shade of leaves to run under the sun during midday in the summer, and the utilization of fired clay pots to cook the tubers of certain plants when food resources were scarce. They appeared to have a contented and uncomplicated existence. Nevertheless, they were susceptible to natural calamities, animal attacks, diseases, and accidents intermittently. At the time, human beings lacked the knowledge and ability to control natural disasters and accidents. As uncertainty heightened anxiety, people naturally pondered the idea of identifying the cause. At this point, humans began to connect with gods, albeit slowly. Abductive reasoning is mainly used to track the causes of disasters and accidents to their underlying determinants. When unable to identify exactly what causes disasters, people tend to think of uncontrollable natural bodies and forces as gods. During the early stages of systematic abduction, humans directly personified natural phenomena, including fire, thunder, water, and the sun, as entities with strong willpower, human-like senses of right and wrong and emotions. Subsequently, humans began to deify various animals and plants believed to be associated with mysterious occurrences. As human ancestors' ability for abstract thought advanced, the concept of a deity independent of natural elements emerged and gradually gave way to man-made objects like totems and gods. Simply put, deities were further differentiated, giving rise to numerous natural and social gods. Humans expressed worship and respect to the gods through various rituals to escape divine punishment and gain blessings. The emergence of committed priests led to the amplification of fictional stories and images of gods and goddesses. The search for causality gradually spread throughout human life as a primitive way of thinking. The ancient Egyptians believed in and worshipped numerous gods. Various gods had different depictions, with some taking human and others animal or stellar-related forms. Different gods were worshipped in different regions, each having specific attributes such as the god of agriculture and the god of the underworld. Thousands of ancient Egyptian gods have been attested to, and the temples used for sacrifices were quite magnificent. The rituals became some of the most solemn religious practices of the ancient Egyptian dynasty, with priests as agents of the gods wielding considerable power second only to the pharaoh. Polytheism evolved from natural disasters, while monotheism arose from man-made disasters. As society grew more populous and denser, natural calamities became gradually insufficient to worry humanity, giving way to man-made disasters. The partitioning of societies, the formation of hierarchies, the fight for dominance, and the envy, deception, larceny, looting, and slaughter born out of avarice became increasingly perilous and injurious to human cognition and corporality. The emergence of monotheism, worshipping the Almighty God, can be regarded as a resolution to the perplexities and anxieties of the people at that time, brought on by human disasters. It was a timely occurrence that satisfied the urgent need for solutions. In addition, the teachings of monotheism were often narrated in the form of stories, and their ease of recitation led to a comforting effect that was readily apparent. This explains why the propagation of monotheism amongst the masses increased rapidly. Judaism, a monotheistic religion, and its derivatives, Christianity and Islam, as well as Buddhism, which originated in India, all attribute human evil to an innate or past life consequence similar to original sin. These religions teach their followers to accept the suffering and anxiety they endure in the present as a natural process of atonement in this world. Moreover, these teachings emphasize that only by adhering to these teachings can followers be rewarded after death. The biblical story of man's connection to God started with the theft of the forbidden fruit, leading to the knowledge of good and evil. The motivation for human abduction is not only to establish a connection with the divine, but also to provide a scientific explanation of natural phenomena using a different perspective for changes in how humans process information. Following the formation of human speech center, the brain's hippocampus primarily processes and stores information related to message associations, no longer being overwhelmed by excessive clutter of information. The majority of the human brain's energy is utilized for sorting, associating, and extracting information. If a Homo sapiens individual wakes up one morning and discovers that the grass, trees, and land outside the cave are wet, it creates a persistent information gap in their brain. As a result, human curiosity drives various explanations for such natural phenomena, and eventually, the rational explanation is that it rained last night. By continually testing and verifying natural phenomena in this manner, humans can strengthen and expand their understanding of the world based on numerous cause and effect correlations. Given that abduction is an innate ability for humans, inductive and deductive reasoning should also come naturally. Inductive reasoning is initially employed to test and eventually confirm abductive reasoning. Deductive reasoning refers to the process of inferring conclusions from established premises based on rules. Concentrating on what can be concluded from the given premises, it is the reverse of abductive reasoning. An illustration of this is that since it has rained, the grass is now wet. Inductive reasoning was subsequently applied to generalize and consolidate deductive reasoning to forecast potential future information based on various known sources of information. If you notice that the forest is damp after every significant rainfall, you draw the conclusion that the forest is damp every time it rains heavily. These two forms of reasoning immensely please human inquisitiveness and further intensify this desire, propelling human cognition to augment. Traditional logic as a distinct body of knowledge was established later by Aristotle. Prior to that, logical reasoning existed in a relatively natural and rudimentary state in the human brain. Individuals were capable of processing only a limited amount of information. The majority of the population processed information unconsciously, influenced by their own experiences. Moreover, knowledge processing and overlap occurred at a relatively slow pace. As the social division of labor and human cooperation became more complex, some individuals specialized in knowledge processing. Next, natural philosophers emerged who professionally organized significant information. These natural philosophers used logical reasoning to extrapolate the information, expanding and deepening knowledge, equivalent to adding a super-powerful engine to human cognition. From traditional logic to modern times, human thinking and reasoning have extended to wider areas. Bold assumptions about the unknown can be made by anyone and confirmed or refuted by others. Proposing hypotheses and engaging in multiple arguments has evolved throughout the course of human civilization as more people participate and advance knowledge from one generation to the next. This process has significantly expanded human understanding of the world. From organisms to non-organisms. The distinct connection between humans and the world is not based on domestication, but on the relationship between humans and abiotic entities. Human comprehension and use of abiotic energy has surpassed the insurmountable barriers between organisms and non-living things, endowing them with value that goes beyond their intrinsic worth. The direct use of abiotic energy and its indirect use through fusion and creation processes have seemingly subjected abiotic entities to domestication. Currently, outstanding human achievements in conquering and mastering abiotic energy have exalted humans to such an extent that the next generation is less prepared to acknowledge their superiority than the previous one. The understanding and utilization of abiotic energy may have originated with primate evolution, but the most significant milestone was certainly the advent of stone tools. During the Stone Age, humans were capable of crafting diverse tools from various types of rocks for specific applications. Flint and hornblende were honed to serve as sharp cutting tools or weapons, while sandstone and basalt were utilized for crafting stone grinders like hand mills. Stone tools were employed to process bone, wood, and other organic resources, which were transformed into usable abiotic energy for broad-scale use. During the later part of the Stone Age, Homo sapiens began utilizing materials like clay for manufacturing pottery. With time, the cooking of food evolved from mere grilling to diverse methods like baking, boiling, and roasting, ultimately highlighting the omnivorous nature of human ancestors. The Age of Red Copper was likely the first major period in which humans developed a significant connection with this metal. The durability of red copper products increased food storage, enabling humans to be more resilient against the risks of drought, flood, and insects. This made it easier to undergo mass migrations. The Bronze Age may have marked the start of human settlement patterns due to the greater stiffness of the alloy formed by mixing copper with tin or lead, which made the agricultural implements more durable and practical than those made of pure copper or pure tin. However, casting bronze required a relatively advanced set of smelting and casting techniques, including mining, smelting, mold making, turning, dosing, and polishing. The emergence of the bronze casting industry represents a major milestone in the history of science and technology, as the connection between humans and inanimate objects transitioned from the imitation of natural red copper and forging to a more systematic casting technique. The emergence of various human civilizations in the Bronze Age is a significant landmark. Bronze can be categorized into three significant groups: production tools, weapons, and domestic utensils. The production of tools like shovels, hoes, sickles, axes, and chisels played a critical role in advancing agriculture and craftsmanship. The broad use of conventional bronze weapons such as knives, bows, swords, arrows, and armor contributed to a significant increase in human casualties, replacing intercommunal battles with full-scale wars involving ethnic groups and fought by professional soldiers. In the Bronze Age, the Aegean civilization experienced the emergence of both small and large civilizations that demonstrated prosperity in various domains such as politics, trade, religion, architecture, and art. The Mycenaeans had already established a clear social division of labor and hierarchy. Bronze household objects became a symbol of power and status for the nobles in the royal palace. The rise of the Age of Empires was fueled by the advent of the Iron Age. Iron first appeared in ancient Egypt and Mesopotamia, two centers of civilization. Although iron was used in minimal quantities by 4000 BC, it was mainly obtained from meteorites instead of iron ore. Between 3000 and 2000 BC, the Hittites in Asia Minor acquired the knowledge of iron smelting, which enabled them to manufacture iron weapons that increased the power of ancient Egypt and neighboring kingdoms. The Hittites, with invincible horse-drawn chariots and iron armor, conquered many small kingdoms around them, including Babylon at its peak. Hittite technology pioneered a new empire that, at its zenith, had a population of over 2 million and even stretched into the western part of the ancient Egyptian kingdom. Its downfall was ultimately the inevitable outcome of years of warfare. Following the collapse of the Hittite Empire, its confidential iron smelting techniques started to disseminate. The advancement in weapons technology led to the intensification of wars worldwide for the expansion of their respective empires. Wood was the primary source of energy required for iron smelting before the invention of coke technology. The consumption and production efficiency of wood reached a bottleneck stage as iron usage expanded to non-military applications. In England, where coal was abundant, it was a more cost-effective and hotter alternative to wood for burning. Despite its affordability when compared to wood, burning coal with iron ore would cause impurities to contaminate the iron. Thus, refined iron produced would essentially be scrap iron. During that time, people could not rely on coal instead of wood to smelt iron. It was only in the mid-18th century that the British discovered a way to utilize coal by initially burning it to create coke, which extracted impurities during the process. As a result, coal could indirectly be used as a raw material for iron production. Thanks to the utilization of coke, the smelting of iron was no longer dependent on wood and resulted in a sharp increase in iron output. In the end, affordable and efficient abiotic energy overtook costly and inefficient biotic energy as the primary source of power for industry. However, once the challenge of energy supply was overcome, another obstacle of oxygen supply arose and hindered further iron production. Before the invention of steam engines, iron furnaces used a water wheel to supply adequate oxygen, following the same principle employed when we turn on the fan for the furnace fire. Unfortunately, the supply of power water is limited and no longer provides sufficient airflow to produce iron. As a result, the smelters of that era were relatively small and had low outputs. The first steam engine in the world was invented by Thomas Newcomen, a small ironmonger in London. Later, James Watt improved the design to increase efficiency by 5 times that of coal. The birth and widespread use of the universal steam engine were fueled by new inventions and technological improvements. This marked the beginning of a new era in which humans became connected to non-biological energy sources. In this era, the amount of energy needed and consumed directly by the human body decreases, while energies that contribute to one's quality of life, spirituality, and are associated with human connections that occur outside of the body take on an increasingly significant role. With the Industrial Revolution and the improvement of steel smelting technology, various unprecedented industrial products such as spinning machines, trains, automobiles, ships, telegraphs, telephones, etc. began to gradually emerge. After being endowed with human intelligence, technology that is related to non-biological energy became a representation of a country's military and economic strength, a tool for earning money in business, and a consumer product for people's lives. Humans did not want to go back to the days of slash-and-burn agriculture, and became increasingly comfortable with their association with abiotic energy. Modern science began to emerge in Europe in the 16th century, with breakthroughs in mathematics, physics, astronomy, biology, including human anatomy, chemistry, and other fields. Throughout these successive improvements, human vision and perception of the world have evolved. Scientific knowledge has created a stronger connection between humans and the natural world, including the universe, altering our perception and understanding of its vastness. The most significant change is that the connection between human beings and non-living energy has shifted from the macroscopic to the microscopic realm. The discovery and utilization of atomic energy have introduced humans to the truly immense and intimidating scale of energy. Even today, in the digital age, we have yet to satiate our greed for abiotic energy, and we continue to develop an ever-expanding energy empire without limitations. Might we in the future experience an abiotic energy rebellion? Might humans become subjected to the destructive recoil of abiotic energy? Chapter 4.